I am going to make sure that we want to go ahead and identify u. And so best u here is going to make that u is x to the third plus 8. Now, du dx is just equal to 3x squared. And I'm just going to make this a little bit smaller, which means du is equal to 3x squared dx. So we don't have any variables that we need to go ahead and solve for here. We have that x squared piece of it, but we do know that dx is then equal to du over 3x squared. So I can make those substitutions pieces, but remember that right now, this -2 and this 4 are for x. Are for the g of x function. So let's go through and change the first portion of it. I'm going to leave those missing for just a second while I go through and write this down. So right now I know that what I have is x squared, and I'm doing this out step by step just to make sure this becomes x to the third plus 8 squared. All of this inside here is going to become u, and then dx is just du over 3x squared. So now I can go ahead, and again, I'm leaving these limits of integration blank right now, not because they're going away, but because I want to take a second to talk about what's going on. Now that 1/3 I can go ahead and pull out front, and I'm left with just u squared du. So we now have to go through and talk about what those limits are. Well, what does u equal? If I come back up here, u is just equal to x to the third plus 8. So the upper limit becomes u is equal to 4 to the third plus 8, which is going to give me 72. And then the bottom limit gives me the fact that is -2 to the third power plus 8. So that is equal to 0. So the 1/3 just stays out front. Now I'm changing the notation. I'm doing the integration. So this becomes 1/3 u to the third, evaluated from that new piece 72 to 0. Now I'm bringing this up because I want to make sure that you change this notation. I can't remember, actually I don't know who did this, but there's 2 or 3 of you on the homework last time that after you did the integral, you left the integration symbol coming down. So please make sure you get that out of that notation. Now I just go ahead and plug all of that in. And I'm left with 1/3 times 72 cubed minus 1/3 times 0 cubed. And if we do all of that out, it will equal 4,041, 472. Inside portion of this equal u. So I want to go ahead and say u is equal to 2x minus 1. Then I go ahead, and we're going to need this time, solve for x. add 1 and divide by 2, so I get x is equal to u plus 1 over 2. Next, I take du dx is equal to just 2. Du is equal to 2 dx, or dx is equal to du over 2. Let me go back and put that dx inside there. You absolutely have to have that. That we remember to change those in a second before I put that in. So we do have complex fraction here. So x is equal to u plus 1 over 2, all divided by u to the 1/2 power. Dx becomes hold on. No, you're right. It's dx. It should be du. Sorry. Yeah, sorry. That's just what happens is I'm thinking about the fact that I have to do something too, and I wrote a 2 instead of a d. So yeah, dx is du over 2. And now we get to simplify all of this. All right, so there's a couple ways to go through and simplify it. I'm going to go ahead and just do it on the side. I think it's probably important for us to do this first one this way. So I have u plus 1 over 2. That's the first part of this, correct? The du kind of hold off to the side for a second, but what I'm really saying is I'm dividing all of this by 2u to the 1/2. That means you're really multiplying by the reciprocal. So that gives me u plus 1 all over 4u to the 1/2. And that looks a lot more manageable. I'll pull that back up. So I'm going to take, actually, I can leave it like this for now. So that's u plus 1 all over 4u to the 1/2. Bring that du back down. Now let's go ahead and put our limits in there. So again, the limits of integration, I know that u is equal to 2x minus 1. So when x is equal to 1, that gives me the fact that u is also equal to 1. When x is equal to 5, I know u is equal to 10 minus 1 or 9. So I'm going to go ahead and replace those limits. So now this is going to be 9 over 1. I'm going to take out that 1/4. These are my new limits. This now is written in terms of u. Now, I can't leave it this way. This is again u over u to the 1/2 plus 1 over u to the 1/2 du. So now I can rewrite this as 2 separate pieces, and I can finally do the integration, and that gives me u to the 1/2 plus u to the negative 1/2 du. And I am left with 1/4 on the outside. Remember that 1/4 stays all the way on the outside. Again, I am just adding 1, but I'm adding 1 in the form of 2 over 2 to both of them. And then when you divide by the fraction, you just take the reciprocal. So that leaves me with 2/3 u to the 3/2 plus 2u to the 1/2 all evaluated from 9 to 1. So just watch your signs when you're going through and putting this in here. I have, just to go ahead and first substitute in 9. So I have 2/3 times 9 to the 3/2 plus 2 times 9 to the 1/2. And then I subtract out the bottom limit, and I have 2/3 1 to the 3/2 plus 2 times 1 to the 1/2. You can put all of that in your calculator, and you should get 16/3.